Right, hello. I hope we are doing well. I had a rather obscure idea. I wanted to see if I could set up a circuit to control the pitch of the sound that is output by a Tesla coil. Um, and it seems like it's going to be quite a big project. I've got a buzzer arriving very shortly that I'm going to use to first test the circuit and build a couple of different iterations. Uh, One of the different ways that I've seen that you can control the frequency that is output into the Tesla coil circuit is either with a 555 timer, and since we've got one of those, we're going to give that a go. And apparently, a better way to do it and a more accurate way is with an Arduino. So we are probably going to end up getting one of those, seeing if we can make this work. And this is going to end up being a three-part series. The first part is going to be setting up the circuit and trying to get reliable frequency outputs from the buzzer. I hope I've ordered the right buzzer. If I haven't, that's going to be a bit annoying. And then the second part will be building a Tesla coil that is loud enough or has enough energy to actually output a sound rather than just sparks. And then the third part will be putting this all together. So I hope you enjoy it. It's going to be quite a long project. Luckily, you shouldn't be seeing too much of the actual full length of it, but I reckon it's going to take quite a while to do. So I hope you enjoy, and why don't you come along for the ride? So we've got our buzzer here. As you can see on the back, we have a positive and negative pin. Now this is a passive buzzer. Looks like this. Got a bunch of information here. This is a passive buzzer, which means that it doesn't have an internal circuit that regulates its frequency. We need to set up a circuit to regulate its frequency, and the values of the resistors and capacitors that we have in the circuit will decide basically what the frequency produced by this buzzer is. So yeah, we're going to dive into it and see if we can build a circuit to get this to work. Okay, cool. So obviously it's unfortunately changing pitch a bit. I'm not sure if that's worth components heating up. And I haven't wanted to run it too long yet because I don't want to possibly burn out any of the components and have to go get more. But what I'm going to do is there's a formula. I'm going to see if I can put it up on screen now. That one can use using the resistor and capacitor values in your circuit to calculate the frequency. So I'm going to use that formula. I'm going to compare it to the formula that to the pitch that I will read off of this using my phone. You can get like apps that you use for music to basically help you like, tune your instruments, whatever. So I'm going to use one of them, and we'll see if the theoretical frequency and the actual frequency are comparable. And from there, we're going to see if we can build on it to make it more variable and control different possible note outputs before we take this any further. So, yep, let's see how that all goes. Yeah, so I've put in a lot of time today testing different resistor values and capacitor values, and I've been able to come up with quite a few different notes, like with pretty accurate pitches to the notes. It's been a lot of work though. I think maybe about 5 hours that I put into it today. It's been a bit long, and unfortunately some of the pitches are still changing. I've got it slightly more accurate now. we're gonna see if we can make this work. It's quite a tedious one. Like I have to change out the resistors and make sure. I ended up doing a spreadsheet just to make sure I could keep track of the different things, but making sure you're using the right resistor values, right capacitor values, and I must admit it's been a bit of work. And as much as I do like the physical and the tactile, actually having the button and a whole circuit with the only like chip being the 555 timer and nothing like coding wise, because honestly I have no clue how to do any of that, so we're gonna have to learn that. I do think that it'll be highly beneficial to use an Arduino with this, because yeah, this is quite a challenge. If I can make it work, then it'll be great, but I'm going to try with an Arduino as well. Went to go try buy one yesterday, but unfortunately they didn't have one in stock, the kits I was wanting to get, so we're going to get one soon. I'm going to try it with that and see if we can get better results with that. So yeah, show you the spreadsheet just to see what I've put together, and yeah, we're going to carry on trying. We have the Arduino here. We went and we got it, and you are not going to believe how much easier this makes it. I was testing it just now, and the hours and hours and hours I spent on the 555 timer circuit, like trying to get the different, the circuit actually wasn't too bad, it was pretty quick, but trying to get the different frequencies was so long. And this just got some code off the Arduino website along with the specific circuit, and in the code you are able to put in what frequency you must play. And it is so easy. It is so much easier. I cannot believe how much time I spent with the other circuits. And all I needed to do was, okay, I was doing stuff with, I was using the circuit with components that I had. I wasn't going and buying more stuff, and I did have to pay a bit for this and the kit, but it's so much easier. It's crazy. It's such a big difference. Okay, so here we've got our Arduino. It's already plugged in. We've got the code uploaded that you're going to see now, and literally all we need for the circuit is we've got the same passive buzzer from the 555 timer circuit. We've got two these DuPont wires and the Arduino. Since we're just going to leave it connected to the computer, we're not going to need another power source, but I mean it is literally this just simple. So we're going to take the buzzer, have the negative pin go into ground, and then we're also going to take we're just going to use red so it's easier to, black for the ground so it's easier to see, and then the other pin goes into and that's it. It is literally that easy. So with the code, what it says is like the sound goes for 1 second and then it's off for 1 second, and let's just check if we move this around. It is literally this easy. Okay, so then what we're going to do is we're just going to change the frequency quickly to 440 hertz, which is like the frequency for the A below middle C on a piano. And it says it's done uploading, so now let's it's that easy. Like, how crazy is that? That was literally all that there was to the circuits. I didn't speed anything up there. I was talking while I was filming, and that's one of the magical parts that I've discovered so far about this little thing that won't focus. There we go, now it's in focus. But I mean, literally, literally it was that easy. It does kind of make me question why I spend so much time on other circuits, but I mean, there was something very aesthetically pleasing I found about like the button and the tactile button and all of that. But yeah, we're definitely gonna go this way, because you can play a bunch of different notes. Like, you can put it all in one code and then it'll spit it out for you. So yeah, first part done. Now next part is we're gonna give the Tesla coil a go and see if we can make this thing work. But this is ending much better than I was expecting, so let's jump into the next one.